Hey everybody, Matt Marrash here. Thanks to special request on Twitter, I'm doing a video today about the Bellows extension factor and how it applies to large format and some forms of medium format photography. Well, in the world of large format, we obviously focus on something by moving our lens on this rack here forwards and backwards. The closer we get to the film plane, the closer we're approaching infinity, the closer we get or the further away we get from the ground glass, the closer we approach something that's infinitely closer. So to focus up on, say, my hand here, the bellows would have to rack out super long to get very close to my hand. But to get something very far away, say, all the way down the hallway there, it would have to be a little bit closer. And it all depends on the focal length of our lens. So I'm using a pretty wide angle lens here, a 210 millimeter lens, and that is roughly 8 1/4 inches. So let's say I want to do a very close-up portrait. Say someone standing about right here away from the camera. So pretty close, within 5-6 feet. I'm going to have to rack the bellows out pretty far, but I'm also going to have to compensate for that due to exponential light fall off with bellows factor. So what is bellows factor? Well, the bellows extension factor, I've got this all written out here, is the extension of the bellows over the focal length of the lens and square that, and that will give you the factor by which your bellows is extended. So I've already got this measured out, but let's just, for posterity's sake, measure this guy out, and we are at just about 12 inches of bellows. And if we're not, well, that's the number I calculated. So we have a 210 millimeter lens. For all of us Americans out watching the video, that's 8 1/4 inches. I don't know anybody else that needs to know that, but that's 8 1/4 inches. So we're going to stick with that because we have 12 inches of bellows. With 12 inches of bellows, over 8 1/4 inches squared is going to give us about a factor of 2.12. Since we're at a log base 2 function for stops of light, so twice the amount of light is 1 stop plus or minus. So a factor of 2. To translate that into stops of light, log base 2 of 2 is 1, so that is 1 stop. When we get a factor of 2, 4, 8, 16, it translates to 1, 2, 3, and 4 stops of light. What happens when we get an in-between number? Well, if we get something, let's say, in a factor of 3, you're probably looking at something like 1 2/3 stops. So if we are at f5.6, I would shoot it maybe at 7.1 instead of f8. If you're going to translate to shutter speeds, you would go from maybe a 60th to a 1/100th of a second instead of 1 over 1/25th. So that's how it translates to stops. A real simple rule of thumb that I use, because I'm using this focal length lens for close-up portraits in my 8x10 Polaroid project all the time. And when I do it, and I'm racked out about this far, roughly every 50% of bellows extension, I'm going to add 1 stop of light, just by default. With some lenses, it's a lot easier to rack them out. Wide-angle lenses are notorious for suffering from bellows factor. I have a super wide-angle lens, 121 millimeters, and I never focus that guy at infinity because I'm always real up close, just trying to get every inch of detail that I can. So what do? Well, when I'm metering zone system style, I know I'm always really racked out on bellows, and usually by the way I looked at my well-developed negs, that I'm probably going to have to compensate 2 stops every time I take it in an indoor setting. So if I were taking a portrait here today, right up at the black thing, I would take maybe a stop and a half for bellows, a little bit further back, half stop, and then all the way back. It's not going to need any compensation. So there's a lot more sophisticated ways, even more so than this calculation right here. This is a rough estimate for calculating your bellows factor. You can measure an object in the picture in the center of the ground glass, and then measure it on the ground glass, and then do the same extension factor, and that will give you an even more accurate reading. But for those of us a little less technically inclined, I use, for every 50% extra of the focal length that you're drawn out, give it a stop. And I mean, you can eyeball this. If you're shooting black and white negative film, or even color negative film, you're going to have a lot of leeway with that in your image. But for those that really need it super accurate, using chrome, just use the bellows extension factor that you see here. So thanks a lot everybody, and thanks for watching.